So we're going to use this baby right here. Our distance equals speed times time. We're not going to go into like direction, like, oh, if it's going up, it's positive, down is negative. Like, we don't have to worry about vectors, scalars. We're keeping it simple here, okay? Which is nice. Now, do you remember doing these in grade 10 and you made a chart? Yeah? We're going to do the same thing. No. Okay, well, maybe you didn't make a chart. We're going to set it up the way most of your teachers probably set it up last year, was with a chart. And so we're going to use that formula of distance equals speed times time. I'll try and use the word speed and not velocity, the best of my ability, for those of you who are physics fanatics. Okay, so in these problems, you're going to have two situations always. So it might be two different type of automobiles. It might be two different people. Two things. So in this case, two first words tell us what those two things are. And that is Robin and Carl. They share the driving on a trip from Cranbrook to Revelstoke. They drove for equal lengths at a time, but Carl drove 20 kilometers faster than Robin. Carl drove for 225 kilometers. Robin drove for 175. At what speed did each of them drive? Okay, so first thing you want to determine is, or what are the two situations that they keep giving you different information about? How fast did Robin and Carl drive? That's really the question, right? The question we're trying to ask, what speed did each of them drive? So if that's the question, that's going to be our variable. Okay, that's what we're looking for. So you're going to have three columns. One column is going to have just numbers in there that they give you. One column will have your variables in there. And the third column, we're going to use the formula to make. This formula here. Distance equals speed times time. We might have to rearrange it if we're looking for time or for speed, but that's how we're going to set it up. So the third, is there some just numbers we can throw in there that we know about, both Carl and Robin? What numbers can we just throw into one of those columns? Do they give us a distance or a speed of them, or the both, or the time for both? Okay, they gave us the distance. They said Robin was 175. Sorry, Robin drove 175 and Carl drove 225. Okay, so notice how one of my columns will always have straight numbers. Okay, now the next one we want to fill in is what we're looking for. And that's going to be with variables. What are we looking for? The speed of each of them, right? So is there some information they give us about speed? Carl drove 20 kilometers faster than Robin. So who do you want to be X? Whose speed? Carl, should we make X or Robin X? If Carl drove 20 faster than Robin. Robin's speed will be our X because, oops, what did I just do there? I said one thing and I did the other. It's called hypocrite. Okay, so Robin is X and Carl is 20 faster than Robin. How would you represent that? X plus 20. Okay, so do you see how we're going to have one column of numbers, one column where we're putting in the variables, and it's what we're looking for. They actually ask you a question. The third column is now we're going to use this formula of d equals v times t to make an equation. Okay, so if we're looking for time and the formula is d equals speed times time, how do we get time by itself? Divide by v. And so our distance divided by our speed equals our time. So now what I'm going to do is I'm going to take my distance and divide it by my time. Oops. Didn't want to do that. Okay. I didn't want to do that either. But. Okay, so distance divided by my time. I'm using those two boxes to make the third. I'm using the equation to make the third. So distance divided by time. So Carl's distance divided by speed. his time. So Carl, what would I write for Carl? Carl's time. Yeah. X plus 20. So once you get to this spot, now we want to somehow use the equation to make these two expressions. We want to find some information in the problem to relate those two. So we have to go back to the problem and say, okay, what did they tell us about time? What did they tell us about time? Equal lengths of time. It's up there. Equal lengths of time. So those two expressions are equal. Their times are equal. And so we can set them equal to each other. So numbers, variables, formula, equation. That's simple. Every time. Once you get it, it's... Okay, so what am I going to multiply everything by to get rid of that fraction? X and x plus 20. So we're going to multiply both sides by x and x plus 20. So that, get rid of our fraction, right? That's our goal. Let's get rid of that fraction. Do you want to go straight to expanding here? Nope. Okay. So 175 times x plus 20 equals 225x. Is this a situation where you could have cross-multiplied? Yes, right? Just because you have one fraction, a over b equals c over d. So notice how you have 175 times, you need brackets, x plus 20 equals 225 times x. Okay. All right, so expanding. 175x plus 3,500 equals 225x. Then, now what? Isolate. Is it a quadratic, Nadir? No. So what are we going to do? Solve for x by? Good. Which gives me 50. One more step. By 50. So that cancels, which gives me 35 divided by 5 is 7. So 350 divided by 5 is 70. Now we have to answer the question. What was the question? At what speed do each of them drive? So now that we know x is 20. No, x was what? 70. Thank you. We know x is 70. So Robin was 70. What's Carl then? 90 plus, or 70 plus 20 is 90. So we need to write a sentence. Therefore, Robin drove 70 what? Kilometers per hour. And Carl drove, that's pretty slow. But those highways in the mountains, sometimes you have to drive pretty slow. They're scary in the winter. Crow's Nest Pass. Have you ever driven that through the winter? Anyways. Okay, 2 more. Next page. Plane and a train. Guess what my 2 situations are going to be? My son would love this. Planes and trains. A plane and a train both travel 1,200 kilometers. The plane is 8 times faster than the train. The train takes 14 hours more than the plane. Find the speed of both the plane and the train. Okay, so my 2 situations, plane and train. Distance equals rate or speed times time. So what can we fill in right away? The distance, because they both travel 1,200. Okay. Now, what is the next one we want to fill in? Yeah. Do you want to put, what are we looking for? Speed. So that's the one we want to put the variable with. Okay. So in this case, if I was looking for time, then that's the one I'd want to put the variable with. So in this case, I'm looking for speed. So that's where I want to put my variable. So what do they tell me about speed? 8x and x. Okay, so it says that the plane is 8 times faster than the train. So who is x? Train is x, and the plane is 8x, because that's what they're asking us to find, so that's where I want my variable. Okay. What am I going to do with time now, with this third box? So you're going to ignore the information that's up there right now of 14 hours more, because once you have 2 boxes filled in, there's a reason why we have this formula up here, right? So we want to relate this time with its distance and its speed. So what is the formula for time? Distance divided by speed. So we want to use that formula for it to fill in the last box always. Okay? So distance divided by speed. How would I write the planes? 1,200 over 8x. We want to make an expression with the third box always using that formula up above. And then train would be 1,200 over x. Okay? So once we've made that expression for time, that's when you're going to look back and find the information about time. Okay, what is the information they give me about the time? The train takes 14 hours more than the plane, so be very careful about that. What's the relationship then? Whose time plus 14 equals whose time? Okay, so you said the time for the train plus 14 equals the time for the plane. Does that make sense? Think about that. Who's taking more time? The train. So the train's time is already 14 more than the plane. Who's taking less time? Plane. So if we're making these equal to each other, it should actually be what? The plane's time plus 14, because the plane's quick, plus the 14 hours equals the train's time. Right? Another way you could have set it up is a difference equation. You could have taken who's longer, so the train minus the plane equals 14. Would work too. Or you could have done the train's time minus 14, because we're trying to make an equality statement. So let's fill this in now. Train, what's the plane expression for the plane's time? 1,200 over 8x plus 14 equals 1,200 over x. Okay, so be careful with those. It's a common mistake. What are we multiplying everything by? 8x. Let's get rid of the denominator. Would be the LCD. 8x. Well, because if they're both monomials, I don't have to do it twice. I could just do 8x, and this x will cancel, the 8 will cancel, and then also this x will cancel. Because it's a monomial, we don't have to do it twice. All right, so what do we have here? The first term will become 1,200. The 8x's cancel out. Plus, what's 14 times 8x? 212x. Check. Thank you. And 8 times 1200 is 9600. Oops, that's blue. Now, easy? Yeah. Subtract 1200 equals 8400, and then divide by 112. What does that give you? I'll wait till you get that. 75? 75 kilometers per hour. Okay, did they want one specific speed or both of them? Both. Okay, so the train travels at 75 kilometers per hour because x is 75, right? We figured that out now, is 75. And so 8 times 75, what's that equal? 600. Plane travels at 600 kilometers per hour. And there's our answer. Okay. So the last type of question is when you have a current, some type of current. They're current or wind problems. So it's similar, and it's a very similar process. How we set up the variable is just a tad different, but it's mostly the same. So when you have current or wind problems, so like you're traveling up a current, like up a river and then down a river, or if you're flying somewhere, if you ever look at if you have flown on a plane before and you look at your flight, the one way is going to be shorter than the other, even though you're going to the same destination, because one way you're flying with the wind, it's pushing your plane, and one way on the way back, you're going against, slowing you down, right? So it's not always the same time if you ever traveled on a plane, right? Did you know that? I don't know. Now you do. Okay, so Jimmy flew his, yeah, what? For who? Pardon me, I mean. That was rude. I don't know. Is that realistic or no? I don't know. Google it. What's the average speed of a plane? Oh, in this question? Oh. Because it was 8 times faster. So how did we get to 600? Oh, because x was 75, so we knew x is 75. We went back to this part, and then 8 times 75. Yeah. Did someone Google it? Well, the average speed of just a commercial plane. Like, oh, fancy. 500 knots. What's knots? Yeah, everything's in knots. Yeah, so this is slow for a plane. Nice. Fast. Okay. Okay, Jay flew his plane 500 kilometers against the wind in the same time it took him to go 600 kilometers with the wind. So we have against the wind and with the wind. If the speed of the wind was 20 kilometers per hour, what would the speed of the plane, oops, anyone catch that? English types? What would the speed of the plane be with no wind? Guys, put your devices away. Stop drawing on your calculator. Oh dear. Okay, so what are the two situations that we have here? Yes. Okay, so against the wind and with the wind. Distance equals speed times time. Notice I'm saying speed. Yep. Okay, so what numbers, like straight data, can we throw into this table? 500 and 600. So 500 and 600. So against the wind, he traveled 500 at the same time. It took him, with the wind, he could travel 600 kilometers. Okay? Now, what are we looking for in this problem? The speed of the plane with no wind. The speed of the plane with no wind. That's what we're looking for. So that's what I'm going to call x. Okay? And because we're looking for speed, now we have category against the wind and with the wind, but do we have a category of no wind? No. But somehow this variable of x, we should be able to put into speed because we are looking for speed. So they tell us that the speed of the wind is 20, right? So when you're flying against the wind, you're going against it. Is the wind slowing you down or speeding you up? Slowing you down. Slowing you down by how much? 20. So what would be your speed against the wind? X minus 20. There you go. With the wind, x plus 20. And so now that we have that, what are we going to do with our last column? D over V. So 500 divided by x minus 20, and then 600 divided by x plus 20. So now that we've made the expressions with time, we go back and find some information to relate those expressions. What do they tell me about the time in this problem? They're equal, same time. So we're going to take those two expressions and set them equal. All right. Do you want to solve that on your own? Okay, solve that. Did you get it? No? Question? Okay, did you get it? Maybe? Plus 12,000, so 22,000 equals 100. So you should have 220. 220, what is the units? What are the units? Kilometers per hour equals x. Okay. So you're using right? You use distributive property. So 500x plus 10,000 equals 600x minus 12,000. So I brought the x's together by subtracting 500 to both sides. And then I moved the 12,000 because it was a minus 12,000. I had to add 12,000 to the other side to get 22,000 and then divide by 100. Good? Now, is that answering our question? Is that what we're looking for? What were we yeah, right? We were looking for the speed of the plane with no wind. Is the variable represent the speed of the plane with no wind? Yes. So the speed with no wind is 220 kilometers per hour. And that is it. Good? So you have a handout. There's 3 textbook questions. Page 348 to 351, numbers 14, 17, and 18. And then the handout has a mixture of everything. So it has some of the number problems. Notice there's 3 types of problems we looked at. There were the number problems, the reciprocals, right? There were the shared work problems, and then there's the distance, rate, times problems. So there's a few from each of them on the handout. The handout's on the front table. Okay, the worked out solutions are on the math website. I did fix it, so the link is up again. No idea what happened. It's weird. So under 20-1, okay. If you go to our unit, which is rational expressions, and you look down the very bottom here, it says handout solutions. So day 8 handout solutions, those are the worked out solutions. So if you're stuck on the handout, the answers are at the bottom, but if you're not sure how they got them, if you click on that, there's the handout, and then here's the worked out for each one. Okay? So they're there. So you don't have to stress. Okay, so that's the end of this unit. Nothing new. Now you need to know it all by Tuesday. No big deal. No big deal.